everyone. Good morning, guys. Good morning. Okay. Uh, Let us work on another data set. We will work on images data that is actually available within TensorFlow, within Keras library itself. We will just load that and we will build a deep learning model to do the classification. It's classification of digits 1 to 9. 10 digits, we will be doing the classification for that. First, we will load the data and then implement the code to create the architecture and to train the model and to predict and then find the accuracy. Okay, this is what we will do. Before I start, I would like to see if there are any questions, any doubts.
Manikan, can you please upload the one which we did yesterday to the drive?
Yeah, okay, sure. I will
Along
upload
with the
that
data set.
instead.
Yeah.
Yeah, sure. Okay, any doubts, any questions from anyone? Okay, fine. So let's continue guys in that case. First, we will, let me go to collab. Okay, yeah. Okay, we will install. I think it should be already available because it's in Google Colab. Import TensorFlow as TF. Plot as I want to import this also. It's taking a lot of time. Yeah, it's done. I will import this also. Yes. So I will go to TensorFlow library in that Keras library. And like I've said yesterday, Keras is a library built on top of TensorFlow. Just like Pandas, how it is built on top of NumPy. Right? I will go to Keras and in that I have a sub package or sub library called datasets. In that there are many datasets available. I will be using this MNIST, which is nothing but lots of images data. I will just write it MNIST is equal to this. Okay. All right. And what I have in MNIST is nothing but 0 to 9 digits. 0 to 9 handwritten digits, 28 cross 28 size, 28 length and breadth size. Now MNIST dot load, if I have this, I have this method here, load data. If I load the data, it would be loading. As you can see, each image is represented like this. I can also plot it and show. Totally, there are these many images and they are getting divided into 4 parts. 1, 2, 3, and 4. Right? Overall, 4 parts, which means I have X train, X test, Y train, Y test. It's already being given to me in this way. Okay, it's I have it in 2 parts, and internally I have each part is having again 2 more parts. So this is the way I will read it. Okay, and this you will get to know only if you know how the data is actually um, being passed by MNIST. Only then you can create this appropriately, which you can see from library anyway. Y test. Okay, so I will read this. X train, Y train, X test, Y test. Okay. Yeah. Right. So I want to normalize so that everything comes in one axis. So right now what I have is, see, as you know, images, if I have an image, that will be represented in numerical form as a matrix, right? You will have 30, 250, 20, like this. It will be represented in every pixel will be represented in a numerical form. Okay, and we would have 3 matrices also, right? 3 matrices, one representing red, one representing blue, how much red, how much blue it is, and how much green it is, right? For every
Uh,
pixel in this image.
So that means like this RGB like will be a 3-dimensional kind of thing.
Yeah, it is. Yes. So how much red, how much blue, and how much green. So if you combine this much green, this much blue, and this much red, you may get orange as output. I'm just telling, randomly, right? Like that, all colors are made up of RGB, certain amounts of RGB. So we call it as RGB spectrum. Even in um, mobiles and even in TV and all of these, people give this technical specification of RGB, right? So that is how usually colors are actually generated in the digital world. Okay, so anyway, first I will be reading this here. So what I will have is a matrix form. I want to just convert it into one axis. I will just normalize it, and then we will also have to flatten it in the neural network architecture. We will see that. First, let us see this x underscore train tf dot.
Can we get some more information on this picture? Red, blue, green means what exactly this
Yeah.
does?
We will go to CNN model. In that time, we will learn more in detail about images. Okay. Tf dot keras. Here I have utils. In this, I have many methods that are useful. For example, normalize. Okay, and let's see how it is. Okay, so this is how it is. Initially, let us see what it was. 1 second. When I will load it, and if I see x underscore train of 10, you can see the image right here, which is in the form of, if you want, you can see the data, right? It is 28 cross 28 pixel, right? So an image can be made up of many pixels. 28 cross 28 is what this data is made up of, right? Usually we have 1080 pixel, right? And then 4K pixels and so on. This image is made up of 28 cross 28. Okay, and if you see how the data is, it is like this for this one particular image. All of the 28 cross 28. And I will just click on hide the data. This is the image. Now what I have done I have done normalization, which means instead of having big numbers like this, 81, 250, 139, it is getting normalized to smaller range, 0.3, 0.2, between 0 to 1, like this. This is what I did. Fine, but like I said, this alone is not enough. We have to get everything in one dimension also. And I will tell you why we need everything in one dimension. Right, so x underscore test is, I want to do the normalization for test data also. Okay, let's do this. Utils dot normalize. Right, so we have extract and xtest, and now simply I can start creating the architecture of the model. Let's say I will create the model architecture. Okay, I will take Keras dot models. In this I have sequential, right? I've created an object of sequential class. Now here I can do a lot of things like adding layer one by one, right? First I will add a flatten layer. If you remember, in the previous class we added a dense layer, right? 1 second. Here initially we added dense layer,
Yeah.
which means all the connections will be there. Now I am adding something called as flatten layer. Okay, first let me write the code and I'll explain. Okay, flatten layer. And then I would add more layers. I can add dense layer. (128), which is 2 power 7. Okay, activation function, I can take ReLU. Okay, I've done this. So see, you don't have to write code like this, tf dot and n dot ReLU and everything. You can write simple code like how I've written here. That's totally fine. But I'm just showing one more way of writing things, but this is simple and efficient way. Okay, now let us see what I have done here. What do I mean by flatten? Dense, you guys already know. 128 is number of neurons, activation function for each neuron. You already know this. Flatten means let us understand. So right now we are dealing with images, right? How many images are there? I think I'm not exactly sure, but there may be many images. Let us consider there are over 1 lakh images, for example. Fine, okay. And then in the previous class yesterday, we worked on tabular data, churn prediction. Okay, churn prediction, right? And if I have created a neural network structure here, let's say 1, 2, 3, 4, 4 inputs. Two hidden layer, this, okay. Now this I have. So what goes to this input layer? Can you tell me why did I decide only 4 neurons here? In the input layer, why did I decide to have 4 neurons?
Because we are having only 4 features.
We are having only 4 features. And what would be going first in the first particular step? What values will be going here?
The first entry maybe.
Yes, first record, right? First record would go, correct?
Yeah,
Now,
first record.
yeah, so now what would happen for images data when we deal with images data?
Maybe the first pixel, I mean the topmost left
Tensor.
corner.
First
Tensor will-
pixel.
Yeah.
What will you be predicting in the first pixel? What will be the prediction? Here, why am I taking record? Because I know the actual record value and I need to predict the record value.
Okay.
We
Here,
need to-
what? Yeah.
Yeah, in the
It will be
images, like we need to
taking the
take everything
matrix.
in a single line. All the values in the matrix.
Yeah, but what is it that it will go as input? Here, you have told me correctly that first
The
record,
pixel
second record.
values. Pixel values.
Which
Pixel
pixel
value
value?
printed in matrix.
All the pixel values of the image.
Yeah. So to put simply, every image you will pass it. And then this entire image you will pass. It is represented as matrix as of now, right? But you cannot pass matrix because here I am having neurons continuously, right? How can I pass a matrix value here? That I cannot pass. See, this looks like a vector, right? One single record is a vector, right? I can pass it clearly to this particular input layer. But here, when I deal with images, we know that it is represented by a this one matrix form that I cannot pass it as input. So what people do is they will flatten it. That is, they convert the entire matrix into a vector form, which means something like this. You have 20, 200, 3, 20, 8, 6. Right? That will be converted into vector form, something like this: 20, 200, 3, 20, 8, and 6. Right now, everything is in vector form. So I can pass it. I can pass it as an input to this particular input layer. So this will be 20, this will be 200, this will be having 3, this will be having 28, 6, and so on. Okay, is that clear, everyone?
Yeah, clear.
Right? And that is exactly what will happen in this flatten particular method. So it will automatically take the data and then flatten it and pass it on to this particular input layer. And how many will be there? See, here I have 3 cross, sorry, 2 cross 3. This is 2 cross 3 matrix, right? 2 cross 3 matrix would give me a vector of 6 cross 1. Right, as you can see, 1, 2, 3, 4, 5, 6, 6 cross 1. Okay,
Just
similarly,
one question.
yeah.
Can you show one record in the input data set? Not
Record is not there. We have only
I mean one
Ah.
input. We are selecting x underscore train of 10, right? So can
Ah.
you select only one?
that is the one image, right?
Yeah, so that's what you know. Let's take a
No, I'm just-
image, 1 pixel, convert
1
into
pixel.
vector.
Why do you want 1 pixel?
Okay, one image. Font is that law, basic convert vectorization or flattenization.
I will get there. First, I'm just explaining the theoretical part so you understand the importance of flattening. Let us see. See, this is how this image is, right? This is the image. You can consider equivalent to record in tabular form. Tabular format. This is the first record you're dealing with, that is the image, which has 3, right? But that image numerical representation is this.
Okay.
Right? Yeah, now you will have to flatten this. That is, everything will be put in one particular vector. That's it. Right? You can do numpy dot, 1 second. Numpy flatten.
So this X underscore train of
Just
10,
just
this is
just
for
wait.
10 different
No,
digits.
just wait, just wait, just wait. Yeah, so this is, you can see everything is put in one single vector now.
I mean, they confused with the 10, right? The 10 is the 10th position, not the 10
Yeah,
images,
the
right?
index
They're
number.
asking that, yeah, in this index.
Yeah.
And this is basic, right? See, 10, I told you, this is a single image that I am showing you and a record. It's equivalent to a record. So how many are there? You can see this once again. Yeah, so what does this tell you? Can you interpret this?
Yeah.
What is it?
2000.
30,000
Totally,
images.
there are 6,000 images and it is 28 by 28 matrix.
60,000
Sorry,
images.
60,000. Yeah.
Yeah. And 28 cross 28.
Mm.
Because I told you each image is represented in, in 28 cross 28 pixel in this data set. Okay. And if I give X train of, how many images are there? 60,000. If I give X train of 10, it would show me the 11th image, right?
Yeah, exactly.
Yeah. This is very basic. Python, NumPy. See, I have to tell you one thing. It is very important because I can explain complicated concepts. I can simplify it and explain, but nobody should explain everything, continuously. Right. These are some things which you should be aware of now. Initially, it's okay if you don't understand, we can simplify and make you understand, no problem. But if you're still getting confused with this, which means your homework and your practice is not up to the mark.
No, so many, the confusion is not with the array representation or the X of 10. Okay, so confusion is with how exactly the image is represented within the matrices. That's what we want to understand. It's not with
That's
the,
what I've been telling you, right? So far, I'm drawing. See, you just have to wait. Just do one thing. Let me finish for 5 minutes, and then I will ask if there are any questions. Then you can ask because I am the next after the theory. I was going to show all of these and explain. And this is not important right now. You can totally ignore because when we reach to CNN, we will understand more with respect to images. Okay, CNN is a machine learning, deep learning model. That is when we will see more about images. Right now, if you know the basic understanding, it is enough. Okay, but see, did you guys understand an image, how it is represented in numerical form? Is it clear now or still not clear?
Clear.
If it is not clear, you can tell me it's not clear.
yeah, clear.
It's clear.
Okay, and then why am I actually converting it everything into a vector?
Yeah, clear.
Yes.
Okay. Okay, fine. I will also show you this. See this you can see here. Wait, let me also do dot shape here. 28 cross 28. Pixel, the 11th image, right? Shape is 28 cross 28. This is clear, everyone, why there are bracket open, bracket close. What does this mean?
Yeah.
What is this? Why do I have multiple bracket open, bracket close?
One pixel value printed in.
Because it is 28 by 28 matrix,
Hmm.
right? Initially, before flattening, we are having it that way.
Right, correct. And now if I do flatten, I'm just showing in NumPy. Okay, this is using NumPy. You see everything is taken into one single particular vector. And what will be the size of this vector?
784, 28 into 28.
Yes. Okay, so that now what will happen? When I create a deep learning model, okay, output will be one neuron telling what is the class of that image, class 3, class 0, class 1, class 9, whatever it is. And input layer will have how many neurons? 784. Right? That entire matrix got converted into vector representation. You can take it like this, or you can imagine as a row, or you can imagine as a vector. It's all the same thing in different representation. Right? That is what you will pass it to all of the 784 neurons in this particular input layer. Then everything else is same. You can have a dense layer here. You can have 200 neurons here or 50 neurons here. You can have dense connections and then so on. At ReLU you can take here, ReLU you can take here, and here you will take softmax. Because there are 10 possible numbers, 0 to 9 digits, 0 to 9.
Multiple
Okay.
outputs, so softmax, right?
Yeah. 2 binary is also multiple output. It depends upon more than 2 you go for softmax, 2 you go for sigmoid.
Okay.
Yeah. Okay. So now let's come back to model part here. So now I have created flatten, which means automatically I don't need to write how many neurons I need. When flatten is applied, it will automatically flatten and then take the 784 neurons. If it is 28 cross 28, it will be 784. If it is 30 cross 30, it will take 900 automatically. So I don't need to worry. And I'm adding a hidden layer. I can add one more hidden layer. Okay, I'll add one more hidden layer.
I mean, we need to pass input size in the first dense layer, right?
Input size? No, that's what here flatten is doing that.
Okay.
Because yeah, size we don't have to specifically write here. When I do flatten, it will automatically convert that into a single vector, right? With 784 cross 1. That will take care.
Okay.
Yeah. And finally, in the output, I will have 10 particular neurons, guys, with softmax activation. Okay, I created it. So yesterday and today, the differences in architecture are, here we did not specifically mention the number of inputs. When we do flatten, it will automatically be taken care of, number of input neurons, right? And also yesterday in output layer, we had only one neuron, because either it is class 0 or class 1. Anyway, we get prediction between 0 to 1. So I can easily tell if it is class 0 or class 1. Here I will have 10 neurons, because for every neuron, I will have the probability that I will get. And whatever is maximum probability, that will be the final class. So I will have 10 neurons in the particular output layer and softmax activation function.
But should not be to the power 2, 2 to the power n, that last one, or it's excluded.
This one, output layer.
Yeah.
How many outputs are possible?
10 outputs. So
Then why will I have something 2 power n? If I take 8, should I ignore the other 2 possible outputs? If I take 16, should I wrongly classify? If I take 2 power 3, right? 2 power 4. That is 16 particular neurons in the output layer, right? Which means this represents 0, this represents 1, this represents 2. Like this, it will represent 15, let's say. So here you will have the architecture, and image will go from here to here, and then first image got classified to class 1. Okay, second image got classified to class 15. That doesn't even make sense. Why should we wrongly classify something? I should have number of outputs, number of neurons in the output layer, as many outputs are possible. That's what you should not take everything for as a rule. 2 power n is only when we have the flexibility, which is there in hidden layers. I can decide how many neurons I want in hidden layer. I cannot decide number of neurons I want in input layer, right? If there are 4 features, I have to take 4 input, 4 neurons. If there are 4 features that are important, I have to take 4 neurons. If I ignore one of the feature, it is not a complete learning by the model, right? And I don't have control over the output also. If it's only 2 binary class, 1 neuron, otherwise many neurons. In between, I can control. Yeah. Okay. All right. So any other doubts, guys, before I go to the next part? Any questions, any other doubts? Softmax, you might not know the formula. I will explain that. First, I will show the output and I will explain the softmax formula. You can also take tanh. Yeah, we'll just take ReLU now. Okay, so did I train the model here or did I just build the architecture?
Just build the architecture.
Just build the, yes, correct, correct. Now let us do the training part, for which we have to do the compile code, right? If you remember, compile is what I have to use, method I have to use. So DL underscore model 1 dot compile. In this, I can pass the loss function, optimization algorithm I want, right? And accuracy metric if I want to show. So optimizer, okay, first I'll take loss function is equal to optimize loss function, none, optimizer RMS prop. Yeah, let me take sparse. I have this, I'm not sure if it is correct spelling, categorical cross entropy. So yesterday we used binary cross entropy. Now I'm using categorical cross entropy, which means more than 2 classes. And I'm doing the sparse, which means it's just a type of loss function. Okay. Now optimizer, I will take SDG, batch size would be, okay, matrix. Let me take the matrix.
Optimizer SGD, right?
Yeah, thanks. Okay. Okay, I have defined my loss function optimizer and metric which I want to show in the every iteration. Okay, now I will fit the model. That is the building of the training of the model will happen now with the fit method. I have to give X train and Y train. Okay, if you want to see what is there in Y train, let me show that to you. So in Y train, you have this number called 3 at the 11th record. Okay, if you can also see X underscore train of the 11th record, that is index 10, like this. You see, X train has a matrix and Y train has the class called 3. 3. Okay, you can also see more, like let's look at 100 index. This is the X train, and this is the Y train, that is digit is 5. Okay, you can also see separately here. digit is 5. Okay. Yeah. Okay, fine. Right. So I will give X train and Y train to the fit method as usual. And I can define epochs. I have to give epochs. I'll give 10 and batch size. $60,000 records I have. So I will take 10,000 records in a batch. Okay. Yeah. So I will just run this and see how it will get executed. Okay. Okay, accuracy is very bad as you can see here. Right, let us try Adam. A little much better with Adam. Okay, so we will also look in Adam optimizer, we will learn that. But just focus on the model creation part, architecture and model creation part. Right, so I gave 10 epochs, and for every 10 epochs, you can see loss getting reduced, accuracy increased. Finally, it is around 89%. For 10 classes, 89% is definitely very good. We can get even more better accuracy actually. I would take smaller batch size and more epochs.
No, we increase batches also. Right?
Yeah, batch size have reduced, so which means batches have increased. Correct. These are epochs, by the way. Don't get confused this with iteration. Iteration is equal to how many? Can you tell me how many iterations it ran based on the epochs and batch size and data set also, data set size?
60 multiplied by 20. 1200.
60 multiplied by 20. Yeah, because totally there are 60,000 records, and then each batch size is this much. Therefore, there are totally 60 batches, right? And I am running it for 20 epochs. So these many. Okay, 1200 iterations, which means 1200 times the weights got updated. Always remember iteration is talking about when the weight is getting updated, because even in simple gradient descent, we have written code also, Python code, right? Basic Python code. Iteration means whenever we update the weight, we call it as one iteration, right? After every batch or every record or every or the complete data set, whatever it is, whenever we update the weight, then we call it as one iteration is done. And here we are updating the weights these many times. So this is the number of iterations. Epoch is nothing but how many times the entire data was seen by the model. I'm making it see 20 times, right? There is no rule. You can try this as a hyperparameter using grid search, right? 20, 30, 50, 400, whatever you want, you can try. Okay, that is a hyperparameter you have to try based on the data set, data size, and many other things. So right now what happened? Model got built. Okay. Okay, any questions so far? Any questions, any doubts with respect to images representation, data set or model building, accuracy, epochs, whatever it is? Yes.
Actually, I have one doubt. Like,
Yeah.
actually, I missed yesterday's class also.
Hmm.
Uh, Here we are using like a mini batch, right?
Yes, we
Batch,
are using mini batch, correct.
but we have given optimizer earlier as SGD and now as Adam.
Hmm. Yes. So in all of these, if even if I give Adam or SGD, stochastic, sorry. Yeah, right. So there is no particular separate optimizer name called mini batch that you have to give. Right. Mini batch is nothing but instead of applying an algorithm on the entire data, you are deciding it to apply on a batch. Okay. So if you give batch size and you give the algorithm, that will be applied. So I'm doing stochastic gradient descent. This is actually with momentum, right? As per the documentation with momentum, which means all I'm doing is if I don't give this batch size, what will happen is this algorithm will apply on the entire data.
Okay, it will consider as SGD.
Yes, SGD, like entire row or entire data depends on how we give it. Since I've given a batch, it will apply on batch. And there is no rule that I should use SGD algorithm only. Instead of this, I can use Adam also. So instead of applying Adam on the entire data and updating the weight, it will apply on a batch Adam algorithm and update the weight after this batch and after this batch and after this batch. So you don't have to particularly give something called mini batch. That's not the way how the library has been designed. It is designed if you give a batch size, then automatically on every batch, whatever algorithm you give, that will run.
Okay.
Okay. So
Got it.
yeah, we have seen gradient descent, stochastic gradient descent, and RMS prop also. If you want, we can try RMS prop. Not sure if this is the way they are representing it. Yeah, this is the way they're representing it. Oh, 0.99. It's even better. Okay, all right. Any other questions? I want to show the predictions also, evaluation on X test and Y test. Let's go, let us be built.
With respect to data set, I have one more doubt.
Yeah.
For binary classification, we will check the imbalance condition. Okay.
Okay.
If we have multiple classes, if suppose one of the class have very few records, in binary we will apply that resampling techniques.
Yes.
In this multiple class, what shall we do?
We can do the same. Resampling techniques are there. Smooth technique is also there. Smooth is synthetically we will create the data, right? So you have 10 classes. 1, 2, let's say I will take 5 classes. Okay. Here you have 70% of the data. 70% of the data belongs to class 0. And then 5%, 5%, 10%, 10%. Right. So majority is in class 0, class 1, class 2, class 3, class 4. Right. So if you want to maintain a class balance, then you do a smooth technique where you actually generate, you want to have a class balance, right? 1, 2, 3, 4, 5. So this original records will be as it is, right? Here also as it is, but here you will add a few more records, right? Synthetically you will add from the original records. Okay.
Okay.
This is
So
one way.
smooth will work for multi-class also. We can use this.
Yes, you can use. Yes, you can use.
Okay.
If you don't want to use smooth, then what people will do is they will actually resampling, like you said, they will actually take the output, take the data such a way that everything is equally distributed. So they will not take entire data, they will take part of the data. But that is not suggested because when we have the data, we should make sure we use it for learning, right? When we ignore this part, then that's not the best approach, right?
Some information might be lost.
Yes, correct.
Okay.
Yeah. And there are other techniques also. See, some people they will try to do when there is class imbalance, right? Majorly two approaches or two places you can do something to fix the problem. One is on the data. You will either do resampling or you will create synthetically generated data and you will try to balance the classes. Or you can do something with respect to model side also. That is, you will not do smooth or you will not do resampling. You will leave the class imbalance as it is. But some models are robust towards class imbalance. Models are robust towards class imbalance like this. They still work very well. No problem. They can predict very well. For example, naive Bayes model. Naive Bayes model is robust towards class imbalance. It will not be impacted by a high class imbalance. Logistic regression will be heavily impacted. Logistic regression you should not use at all when there is class imbalance. Performance will be worst. Okay, naive Bayes is not like that. And you can understand that when you look at the inherent mathematics behind. Logistic is sigmoid, and here in case of naive Bayes you have probability distributions and everything. So based on that you can understand. But anyway, that's all in ML. This should have been covered to you. No problem. Right. And then even in case of logistic regression, we can do some hyperparameters are there, which will actually fix the problem of class imbalance to a decent extent. Right. So you can do in two ways: data side, model side. You can work on. All right.
Okay.
Fine. Now let me close this. Okay, let us do the prediction on test data and train data. X train, comma, Y train. Accuracy is 100%. It's actually overfit on train data. It's overfit, but that's okay. We have many approaches to deal with overfit, like regularization techniques, dropout, and so on. Right. So now before we go to overfitting issue, we will just see this performance on test also. Yeah, on test 97, on train 100%. 100% means clearly overfit. That too on 10 classes. Right, this is on test. Okay, so you can fix this by adding something called as a dropout layer. Right, and we will particularly see this. We will discuss about the overfitting issue, theoretical part in neural network, and all the possibilities to deal with the overfitting issue. And we will come to this code again. We will fix the overfitting issue as you can see here. Okay. Also, if you want to see this image, I was getting the image also before. Somehow it's not here now. I'll just use matplotlib. I didn't want to use matplotlib, but let's see.
I am sure.
Okay, I am sure. Okay. This is 5, right? And 10. This is 3. Okay, great. Right. So you can use this. And what else is missing? Yeah, we have to look at the softmax function, guys. Okay, let's start that. Right. So activation functions. We have seen few activation functions. Sigmoid is the most basic, and then tanh, and then ReLU, and then leaky ReLU, then softmax. This is very important. Okay, first we will understand the formula for softmax. Right. So it will be e power. How do I take it? I will take it as. We'll just take it as I. Right. See, representation can be different everywhere, but don't worry. Just understand the intuition. I is equal to 1 to n or k e power I. Okay, this is the formula for softmax. It's very simple and intuitive to understand. Okay, very simple and intuitive to understand. Just one example I will give you. Let's say there is 1.3, 5.1, 2.2, 0.7, 1.1. Okay, this one, when I pass it to softmax, right, what will be the output I will get? Okay, so let's see for this what I will get. So here it is nothing. See, it is almost like taking the checking the percentage level, right? But in a different form. So here I would have e power 1.3 divided by e power 1.3 plus e power 5.1 plus e power 2.2 plus e power 0.7 plus e power 1.1. So all of these. So summation of all of the values e power, and in the numerator for whichever value I'm taking, I will take that in numerator. Isn't it like something like I have 10, 20, 30, 20. So what is this? It is 10 by 10 plus 20 plus 30 plus 20. What percentage it is? Right? Similar intuition. Just try to understand what percentage it is. 10 by 60, 80. So it is into 100. If you do, you will get that number, right? So the same intuition I want you to understand for softmax. Okay, but we are taking it with e power. The reason is when we take it with e power, then the range will always be between 0 to 1. 0 to 1. Okay. So now this would be approximately 0.02. And I'm seeing these values online. I'm writing it. So these are correct values, guys. Okay. Like this I will get. Now for 5.1, what will be the value as per the softmax? So simply e power 5.1 divided by, again, like I said, summation of this. I means consider this one. This thing is I. So for whichever you're dealing right now, I'm dealing with 5.1. So e power 5.1, e power 5.1 divided by summation of all of the i's, e power I. So simply it will be e power 1.3 plus e power 5.1 plus e power 2.2, 0.7 plus e power 1.1. That's it. Okay, and this is equivalent to 0.90. 0.90. I will just fill all of the values here. Okay, 0.02. Right. Now also observe this. In this particular vector, right, the highest value was 5.1. Right, lowest value was 0.7. There, this one is 0.02. Okay, highest is this, lowest is this. So it will only make sense that this will occupy the major percentage. Right. For example, if let's say I am having 50 rupees, you are having 100 rupees, and other person is having 10 rupees. So you would be having the maximum percentage of the cash or the share, right? And I would be having second, and the other person will have in the last. So that is exactly how things will be reflected here also. 5.1 is the highest, and that is having 0.9, highest among all of the this thing. And when you add everything, should it sum up to 1 or not?
Yes.
Yes, because you're
Yes.
taking the denominator, which is this, and then dividing it with each, this one, and then this one, and then this one, everything. So it's like you're taking a total 160 rupees, and then 50 by 160, how much you're checking, you will get the percentage. 100 by 160, you're checking, you'll get the percentage. 10 by 160, you're checking, you're getting the percentage. When you add all the percentage, it should be equal to 100%, or it should be equal to 1.0, right?
Yes.
So the same is what here also. You just add all of these, you will see it will equal to 1.0, right? And the highest will be obviously for this one, 0.9. Lowest will be 0.7, 0.01. That's exactly how it got converted. Okay. So this is what is softmax. Very, very important. People will sometimes ask you the intuition of softmax and the formula of softmax. Simply, when if you are not able to recall, simply think of this percentages analogy. You have 50 rupees, 100 rupees, 10 rupees. How will you calculate the share or percentage? Like this. But since we want it in between 0 to 1, you're taking e power everything summation, right? And then here e power. That's it. Okay. Because you want each of the values should be between 0 to 1. Here what happens is I may get that this has 30%, 50%, 20%. So it is not between 0 to 1. Right. If you take e power, it will be 0 0.03, something like that. Right. Within the 0 to 1. Fine. Now, how is this useful is, it is useful because you can see this example in our data itself. Images are there. Okay, 784 cross 1. First record, first image. Okay, and I have 60, 128, 64, 10. Okay. Now here I got, for this particular image, I got, let us say like this. I got some values. It can be anywhere, 1.3, 6.2, 10.1, 1.2, 0.5, 3.2, 2.1, 0.3, 0.2, 0.1. Like this I have. Now this is the output in the output layer for this particular image, let us say, which is 3. Okay. Now this one would have a softmax activation function. Right. After the activation function, softmax, I may end up getting something like this. 0.8, oh sorry, 0.3, 0.5, 55, 0.1, 0.09, 1.2, oh sorry, 0.23. Like this, I will get values. Okay. Now, simply by looking at this, can I tell which particular class it belongs to? This is for class 0, class 1, class 2. So I'll take it as class 2 here. Okay. So 55% probability, highest. So here, who has the highest share in this example? Who has the highest share? Let us say this is me. This is Shruti. This is Kiran. Right. So Shruti has the highest share. Right. Similarly here, this image belongs to which class? Highest, class 2.
Class 2.
Yeah. So that's why it will put this prediction as class 2. Prediction as class 2. Just because it has the highest probability. And because you add everything, it'll get to 1. Therefore, each acts as a probability. In case of binary, what happened? In case of binary sigmoid, we know it is always between 0 to 1 only. Right? Right? So, if you get 0.8, which means class 1, if you get 0.001, which means class 0, you do it easily. But here you have 10 neurons And each neuron can have any value. It can be 1,000, it can be 2, it can be 500, it can be 20,000, anything. But now compare, this is the amount each one is having. Let us see in terms of percentage. So since this is having 20,000 and this is having 1,000, 2,000 like this, it looks like 20,000 is like 55% of the entire thing. Right. Therefore, this record belongs to this particular class 2. That's exactly is the intuition. Right. So whatever values you get from the forward propagation and everything, after applying softmax function, you would get everything in 0 to 1 range, and adding everything will be equal to 1. Otherwise, it's not in terms of probability. It is equal to 1. Okay. So finally, you will see which one has the highest, and you will do that, and the model will do that as a y hat classification. Okay. Is this clear?
Yes.
Yeah, clear.
Yes. Yes. And very, very important, do not forget the formula for sigmoid. Right. People might ask you in the interview suddenly, and if you that is a chance for you to show your skill, right? Your skill, and your level of skill you have, experience you have. So you should utilize it. Right. And you should remember formula for everything. Sigmoid, tan H, ReLU. What is the formula for ReLU? Very simple.
Max of 0, x.
Yes. Correct. Softmax we just saw. Sigmoid is 1 by 1 plus e power minus x. Tan H, does anybody know?
Is it e to the power
Max.
of minus x minus e to the power of minus x by e to the power of,
Hmm.
e to the power of plus x minus e to the power of minus x by e to the power of plus x plus e to the power of minus x.
You are saying it is plus x.
Yeah.
Okay.
My e to the power of plus x plus e to the power of minus x.
Right. Correct. Yes. And this range is between -1 to +1.
Hmm.
Is between 0 to 1. Softmax, the total will be equal to 1. That's it. Okay. Yeah, there are few others also, but these are major important. Whatever comes later, we will see later, because we have other hyperparameters also. And then we are overfitting also, we have to discuss about. Once that is done, see, I will tell you what is next. We will see. Overfitting is what we will see next. How to fix this, right? And then we will be done with basic deep learning model, an ANN model. Okay. Then we will look at CNN model, and then RNN, LSTM, GRU. These three are similar. When you know RNN, you can it's just an architecture change in RNN, which leads to LSTM and GRU. And we have auto encoder, right? That's it. So I think in around 7 days or so, the deep learning class will be completely done. And I focused majorly on the all of the parts for ANN, because in ANN and deep learning, we have many parts. Right? I tried to focus on everything, that is theory, examples, derivation, code, a practical application, right? Everything we have to focus. Hyperparameter tuning, everything we have to focus. That's exactly what I try to do. Then we will also see CNN, RNN, LSTM, GRU, autoencoder. These are next important ones. Okay. Fine. Any questions, guys? Any doubts so far?
Only one question.
Yeah.
For the,
Yes.
the softmax function, I think it is coming with the number of values which is equivalent to the different classes in the input, right?
Yes, correct. That's correct. In the output layer.
Right, in the output layer. Okay. So, I mean, which parameter tells the number of exact classes? Are we giving something in the model builder? Can you go to little up?
Yes.
Not here, the coding.
Code. Okay. Okay.
When we give
Yes.
this softmax as
10, we have given here 10. That's because I know that there are 10 possible digits, 0 to 9. I know in my data, I have images of digits from 0 to 9. So total possible classes are 10. Right. Tomorrow, I may have different kind of outputs possible. Let us say there are 3 classes. That is, it belongs to rich class, poor class, middle class. Right. Given certain details of the customers. Rich class, poor class, middle class. So I have 3 particular classes. So this will be 3. I have to make it to 3. Right. Like in this case, it is 10. Yeah, is it clear?
It is clear, but then I'm just thinking. So, for example, okay, so you trained identification of the digits or certain objects, okay, say with 15 different classes, okay. So when you apply that, I mean, a larger untested data, there could be more number of classes that you can see it. I'm just
more
thinking
number
on a
of
practical.
classes. More number of classes is there, then this won't be the appropriate model to test on, to predict on. How many other classes, if let us say in train data, there are 0, 1, 2, 3, 4. These are the numbers you have trained on the train data. And in the test data, you have images. In the train data, you have images. And possible values are 0 to 4. And in test data, you have 0, 1, 2, 3, 5, and 6. Right. So it is completely different classes. We have different classes here, 5 and 6. So if I take an image, which is, let us say, 5 here, and then I give it to a deep learning model, which got trained on this data, and I give this image to this deep learning model, it will either classify it as either 0 or 1 or 2 or 3 or 4, but it can never classify it as 5. Whereas the actual input is 5. Maybe it will classify it as 3 with highest probability because 3 is looking similar to 5, or something like that. Or it may be put it in 2, right? But it will never classify it as 5. Therefore, if you know that these are the images, you either don't show this to this model, or you create a new model, deep learning model, which has learned the pattern of 5 and 6, right? Which has learned the pattern of 0, 1, 2, 3, 4, 5, and 6. Now this deep learning model, you can give this image because it has learned the pattern of 5 number and 6 number and can predict it. Right?
In practical image classification, I think whatever data that you provide, that should encompass all the possible samples.
Yes. In the training, you should encompass all the possible patterns and samples. Yes, in the training data. Otherwise, model will definitely not get to know the pattern, right? And what you're telling is also something in real world is crucial, because sometimes we will build the model on certain data set, and the as time goes by, the pattern might change, right? The pattern might change, but that will not be predicted by the model because it has learned only a certain kind of pattern. Right? Let's say something like this, but right now pattern is this words. But model will not be able to predict it accurately. So there should be continuous updation of the model. We call this as data drift. That is, pattern is changing compared to see, all of this is under the hope and assumption that future will be equivalent to past. Right? But there is no guarantee, nothing like that. Future can be very close to past or not at all equal to the past. Right. When it is not at all equal, all your models will fail eventually.
Yeah, I mean,
right?
That's where we periodically retrain the models.
Yes. We have to identify, okay, this is the point where model is failing, and it is not because of something wrong with the model, but it's because the pattern itself is changing. The pattern is getting evolved. It is changing. Right. So it will, now you have to train the model. For example, you take stock market prediction. Suddenly COVID hit and all market fell. So 2 days before COVID, no model in the world would be predicting that all the stocks will fall by 10% or 15%. No machine learning model or deep learning model was able to do it because such a COVID, pandemic impact, such a thing never was part of the train data historically, and never was shown to the train data as a form of pattern to recognize. So that was never part of it. So therefore, the model failed to recognize such a kind of pattern in real world that could have occurred and impact the stock market. Right. So it failed. So now what will happen? People will develop a better models with taking the geopolitical factors also into the model, like the what is news articles you can take across different countries, and then analyze the global impact and then make it predict on the stock impact. Something like that we can do. That is a better version model, improved model. After COVID is impacted, then people started doing it. Right. So that is the example. Okay, so whatever classes are there in train, same is what you can use in the test data. Anything beyond that, you can give it as an input for sure. Nobody can restrict you. If this image is having 5 number, you can give it as a input to this deep learning model, no problem. But it will classify only among 0, 1, 2, 3, and 4 because it has only those patterns it has learnt. Okay. If you want, you can take something called other. If you want to be smart, you take 0, 1, 2, 3, 4 and others. Others. So others can be of multiple uh, patterns inside it. If it is not 0, not 1, not 2, not 3, not 4, it will go into others. Something like that you can do as a smart technique to at least reduce the error percentage. Okay. Fine. Any other questions? We have only 5-10 minutes left, so let me not go to new topic. Any other questions, guys? Yeah, can you please send me the Google Drive link? I will upload this code files. I think I missed it. Please send the Google file link, Google Drive link, guys. Yeah, thank you. So I want you to implement the code on your own. It is very simple as you have seen here, right? It's hardly 10 to 12, 15 lines. That's it. Very simple. I already gave you the intuition of each line. Sequential, adding, add method, dense, flatten, activation function, right? It's all quite intuitive. You just have to get used to it. Maybe 3 to 4 times if you write the code, it will be very easy for you to write the code next time without seeing anything, without using internet. You can write it straight away. It's very simple like that, right? And data set also you need, right? Yeah, both the files are added and data set is added. And images data directly I have loaded from Keras, so there is no data, zip file or anything for images. It's directly from Keras library. Okay, let me bookmark this so that I save it for future. Yeah. All right. Any questions? Anyone else?
Manikant, we will not be learning NLP. Can you tell what is that all about?
Yeah, NLP, right. So when we learn CNN, it will be on images data. When we learn RNN, LSTM and GRE, it will be on the text data. So I will explain a little bit about NLP, but NLP is like a separate subfield altogether. There are a lot of basic concepts that we should know in NLP, like text to numerical representation, different ways of numerical representation, all that we have to know. That's a separate this thing. Deep learning is majorly about the models that we will be using. So whatever is required in the NLP knowledge and idea to understand the deep learning models, I will explain that. Okay. But we have to finish the deep learning models also first. Right now we have 4 to 5 more models, and then obviously optimization functions are 2 optimizations are left: RMS prop and ADAM. It will not take much time. It's simple. It'll not take much time. It will be done in one class or so, and then CNN, RNN, LSTM, we will see theory and also practically implement.
What are the frames that we cover? Like normally now we are doing with the TensorFlow. Similarly, we'll be covering the NLTK
Yeah,
and
yeah, yeah.
OpenCV and everything.
Yes. We have CV, OpenCV, NLTK, Spacey, we will use these. Actually, in TensorFlow itself, you can create RNN, LSTM, Keras itself you can create. SpaCy and NLTK is useful for pre-processing the text data. That is cleaning the text data, pre-processing, and then doing some NLP related tasks like NER, sentiment classification. Those are all in NLP side. We can do that using Keras also, right? And spaCy also. NLTK
So,
also.
I mean, an NLP as a topic will not be taken in a broader sense.
No, see, I don't know about that. See, I am allocated to cover deep learning.
Okay.
So that is what I am going to cover. I will check with somebody and let you know if you need a NLP, if it's separately covered or not.
Yes. Okay.
Yeah.
Manikant,
Yeah.
like initially we have said like we for our batch few concepts were not covered.
PCA you were saying, right?
Yes,
PCA.
PCA, time forecast, forward selection and backward elimination concept.
Okay. Okay. In linear regression.
Yes.
Okay. Okay. So sure. I will cover that for you guys. Let's finish the deep learning part first, and then based on availability, I will just allocate 2 or 3 days more for your batch, and I will cover that also. At least
Okay.
PCA and important. PCA is very important, that has to be covered. Otherwise, you will not understand autoencoder also. So I will do one thing. When I explain autoencoder, that day itself I will explain PCA, and next day I will explain autoencoder. That would be good flow. Okay.
Oh, okay.
Yeah. So it will be taken care. Don't worry.
Thanks, Manikant.
Sure. Okay. Okay. And if you guys have any doubts in between, you can ask in LinkedIn or anything, even in WhatsApp message also you can ask me, because I want you guys to practice. See, this is my number. You can text me in WhatsApp if you have any serious doubt or any help you need. I will reply. I may take some time here and there based on my work and everything, but I will be helping you out. Okay. It's not just for this particular class or batch to be over. After the batch is over also, you can approach me anytime if you have any questions and doubts. If you have any interview, you want to quickly connect with me, any quick help or refresh you need, please at least reach out to me. Right? Whether I will be able to connect or not based on my time is a different thing, but at least reach out so that when I have the time, at least I will put some text message and I will help you, or I can connect with a quick call and help you guys. Right? Because I definitely want all of you to be have good clarity in all of the theoretical concepts and implement practically, and go to some workplace where you will enjoy the work. Right? And this is not the ultimate goal. You should be reaching towards Gen AI side, because Gen AI is where the complete market is, complete demand is. And then after Gen AI, more advanced technologies will be coming up, like human AI integration, humanoid, and many other quantum computing. So if you reach to that level, only then you will be able to get jobs very easily, multiple jobs very easily, and good pay. If your skill set is in machine learning, everybody knows machine learning, most of them, everyone. And machine learning code can be given by ChatGPT easily, right? Instead of having 10 machine learning engineers, people will have only 5, but 5 machine learning engineers plus ChatGPT, right? But Gen AI is something where huge demand is there, so very few people are there skilled in Gen AI. Supply is less, demand is high. So you should always reach to that level where you know the advanced and upcoming technologies, provided you are enjoying it and you're interested. If not enjoying it, it's okay, you choose something else, but I'm sure you will enjoy. So you reach there. So deep learning is also not the goal for you. This is only one step to go to Gen AI, right? I think I told in the first class itself, deep learning models, when you apply transformers technique on deep learning, attention mechanism, and you take multiple deep learning models and connect them in a complicated architecture, we get scaled up versions of deep learning models, very huge, big, right? And those are called as large language models, which are part of Gen AI, which is capable of generating the output. Right? For example, writing poems, writing code, giving summary and everything. Right now, whatever models we are seeing, it is a point level prediction. Point level prediction means class 1, class 0, image, class 1, class 2, class 5, give loan $20,000, $30,000. It's a point prediction. It's not something like generating a poem or creativity is not there. It's all point level prediction, whatever we have seen so far. After we learn everything, then we take these deep learning models and we have complex architectures like BERT, GPT and everything, which are capable of generating, not just a point level prediction. It can generate code. It can generate poems and poetry, stories, images, videos and everything. So everything, the complete market is in that right now. So you should be able to reach to that level. So I am telling you all this because you guys should be there in that level where jobs are you can get easily. I'm not sure if Gen AI is covered in this, but you should learn on your own or some other way, whatever it is. You have to do it. That is my strong recommendation. Okay. Okay. All right. So that's it, guys. Then I will see you in tomorrow's class. Let us finish the optimizer concept and then overfitting concept tomorrow. Okay. Okay. Thank you, guys. Thank you, everyone. See you tomorrow in the next class. Bye, guys. Bye.